4 more days. In 4 days, almost 11,000 athletes from all over the world will gather in France for the start of the Olympic Games. They will show the world how fast, powerful and agile they are in their sport. They want to excel in hockey, athletics, sailing, or any of the other 32 sports. In 96 days, 81 teams from all over the world will gather in Zurich for the start of the Cybathlon, also known as the Bionic Olympic Games. They will demonstrate to the world their assistive technology for people with a physical disability. They strive to be the team with the fastest and most advanced technology. These two competitions I just mentioned share one overarching theme, which is physical mobility. Physical mobility refers to the ability to move freely and easily, something many of us take for granted. As we watch sports games, we are not surprised that people can run, swim, or cycle. But for people with a physical disability, freedom of movement is not that obvious. They are faced with challenges and obstacles each day again. For people who are permanently wheelchair-bound, like, for example, people with paraplegia, there currently are some traditional mobility aids, like wheelchairs and handbikes, to improve mobility. However, these traditional aids have limitations which exoskeleton technology can overcome. These technologies can't provide the freedom to stand up and walk, a freedom which exoskeletons can give. My name is Kim Adams, and I'm this year's team manager of Project March. And on behalf of our entire team, I welcome you all to the reveal of the March 9 exoskeleton. The exoskeleton we will present to you today is more than a technological achievement. It is a step towards a future where everyone, regardless of physical limitations, has the freedom to effortlessly move and participate in daily life. So before we dive deeper into how our exoskeleton actually works, let's take a step back and see what it takes in a human body to achieve rapid and effective movement. It all comes down to the seamless communication within our body. Our bodies are equipped with a complex nervous system that allows us to react quickly to our surroundings. This system includes the brain, the spinal cord, and nerves, all working together seamlessly to go from detecting stimuli to reacting. Let's consider a practical example. Imagine an athlete at the start of the 100-meter sprint. The athlete hears the start shot of the race. The ears detect the sound and convert it into electrical signals, which are sent to the brain via nerves. The brain recognizes the sound as the start shot of the race and quickly decides on a course of actions, like, for example, starting the sprint. Signals are sent from the brain through the spinal cord and nerves to the muscles in your legs, instructing them to contract. As a result, the athlete will start the sprint towards the finish line. This whole process, from detecting the sound to reacting, occurs within a fraction of a second, showcasing the incredible efficiency of our body's communication system. But what happens when this communication is disrupted? Individuals with paraplegia experience a disrupted connection between the brain and the lower body due to a spinal cord injury. When the spinal cord is damaged, the signals from the brain can no longer be transmitted to the lower part of the body, resulting in loss of motor and sensory function below the level of the injury. Being paralyzed and permanently wheelchair-bound severely limits everyday freedom of movement. Moreover, it significantly impacts the human body. Bones and muscles become weakened, and the blood flow decreases, which negatively impacts the cardiovascular health. In addition to the physical effects, it's evident that being wheelchair-bound profoundly impacts the mental well-being. Since the founding of Project March in 2015, the members have been driven by the same vision. The vision to improve the quality of life of people with paraplegia by pushing the boundaries of exoskeleton technology. An exoskeleton is a wearable robotic device that works by mimicking the function and the structure of the human body. Just as our bones provide a framework for our body, the exoskeleton has a rigid frame that supports the user, giving it structure and stability. The motorized joints of the exoskeleton function like muscles, generating power and movement. The nervous system is mimicked by the electronics. They make sure signals are sent to the motors so the exoskeleton knows where to move. The software and computer housed in the backpack act like the brain, processing all the inputs and controlling the entire system to ensure smooth and responsive operation. To be able to react and adapt to its surroundings, our exoskeleton has cameras that serve as the eyes. Finally, the covers of the exoskeleton function like the skin, enclosing and protecting all the internal components. As you can imagine, building such a complex piece of technology requires an incredible investment of time and energy. Fortunately, the Project March 9 team is a diverse team with incredibly motivated and persistent members. A team of 28 students and a pilot, all so different, yet united by the same goal. Last August, we started together as a team. Within weeks, we got to know each other and the project, and we set our team goal for the year. Our journey included various phases to design, build, and test our exoskeleton. Throughout the year, we had setbacks we faced and achievements we celebrated. We learned a lot from each other, and we grew, not only as a team, but also as individuals. I could go on for a long time about this team and how we experienced this year. But I think that the rest of the team would be much better suited to tell you themselves.
We are Project March 9,
a TU Delft team,
made up of 28 students and a pilot.
All from different study backgrounds,
but with one common goal.
One full-time year.
We set aside our studies
to create an innovative exoskeleton
for people with paraplegia.
What makes March special for me is the dedication that the team puts each year in order to push the boundaries of exoskeleton technology.
Getting to make friends for life.
the people around you.
The opportunity to innovate.
Being able to help people using technology.
Going to the Cybathlon in Zurich.
Being able to take risks and come up with creative solutions.
Technology that's both innovative and also life-changing.
We get to work closely with the pilots and we get to make most of our components ourselves.
The direct impact on our pilots' lives.
The possibility to try new things.
My function can be described as writing software and taking care of communication between our departments and the other departments.
I design the covers of the exoskeleton and the input device.
General programming and working on the brain-computer interface.
Designing software for human-robot interaction.
I stay in close contact with all of our partners throughout the year.
Control is making the exo move the way we want it to.
Form the bridge between hardware and software.
This year I got better at programming and people.
What I've learned is PCB design.
Designing and producing my own parts.
Blender.
I've learned to write lots of code fast and how to work together with a diverse group of people.
Working with different kind of people and developing my surface modeling skills.
Project March, in one word, is team spirit.
A roller coaster.
Extraordinary. Experience.
Self-discovery.
Bloed, zweet en tranen.
Development.
Fulfilling.
Achievements.
Cables.
Gezellig.
Complex.
Challenging.
Friends. Impact. Compromises.
Dedication.
Something that I will never forget is unboxing our order parts for the first time.
When the Exo was assembled for the first time.
The moment that all the parts that everybody worked on finally came together.
At the start of the year when we all met each other and learned all about previous March years.
The first air gate.
The code and to see it working on Exoskeleton, especially when Daan able to stand up.
Seeing sparks on a battery.
With the whole team on stage at the end of the design presentation.
Me blowing up the power distribution board during the first weeks of testing.
At a design presentation when everyone came together to see what we've been working on for the past months.
The moment that Daan stood upright in the exoskeleton for the first time.
The people in the team.
Together, we built an exoskeleton.
Together, we are Project March.
This year, I've had the opportunity to meet and work with some amazing people. And with that, I've made memories that will last me for the rest of my life. And that's important because we set ourselves a challenging goal at the beginning of the year. We said that Project March 9 will build an exoskeleton that will complete all 10 obstacles at the Cybathlon 2024. Within 10 minutes, focusing on a reliable performance of pilot and exoskeleton with a motivated team. I think as you just saw in the video, we have the motivated team part covered. So I'd like to tell you all a bit more about the Cybathlon. My name is Martijn, and I am the data analyst of Project March 9. And today, I'd like to walk you through what it means to compete at the Cybathlon and explain its importance in the history of Project March's exoskeletons. The Cybathlon is an event at which teams from across the world come together to showcase innovations in wheelchairs, prosthetics, exoskeletons, and other assistive devices for people with physical disabilities. Teams competing must complete a set of obstacles or tasks, which represent situations from your daily life. The Cybathlon provides the perfect opportunity for people to demonstrate technical improvement. By organizing the event in sets of tasks or challenges, it creates a competitive environment in which teams are encouraged to find new creative solutions to accessibility issues. And for this reason, it's been since the beginning of Project March that competing in the Cybathlon has been a goal. March 1 started this journey by setting their goal in competing in the Cybathlon in 2016. The next 3 exoskeletons, March 2, 3, and 4, all had their goals to compete in a smaller annual version of the Cybathlon, a so-called Cybathlon experience. March 5 again wanted to compete at a large Cybathlon competition, but unfortunately they got set back by the pandemic. Following this year, the team took a bit of a different approach and decided to focus more on the exoskeleton's ability to perform tasks in daily life rather than being able to compete in the Cybathlon. And these last 3 years have been very important into helping shape our strategy for this year at the Cybathlon, as there have been added obstacles and added complexity to those obstacles. So despite the shift in team goal for these past 2 years, it becomes apparent that since the beginning of Project March, the Cybathlon and Project March have been intertwined. And before I continue to tell you more about the Cybathlon, I'd like to highlight a specific feature of the exoskeleton. When we're at the Cybathlon this year, we want to represent not only our team and our exoskeleton, but also a bit of our roots. And that's why since the beginning of the year, our design engineers have been hard at work collaborating with a local business who produced the renowned Delfts Blauw, combining our sleek exoskeleton covers with their traditional and elegant Delfts Blauw design. And this is why I'd like to give you a sneak peek in the final reveal of the exoskeleton by showing you the final covers. Now that we've seen a short preview of the exoskeleton, I think you may be wondering, what is it like to actually be at the Cybathlon? And to do this, we've collected some fragments of video from the past 9 years of Project March, whether it's at competitions or Cybathlon experiences, to give you an idea of what you can experience when you're actually there. So please enjoy.
Cybathlon is more than a competition. Cybathlon is emotion and innovation. It moves people and technology. Numerous teams from all over the world compete against and with each other with one common vision: a world without barriers.
When you watch this event, you start to believe that is possible. I think what Cybathlon demonstrates is there are no boundaries.
Now that you have a basic understanding of what the Cybathlon entails, I think you may be wondering what exactly it is that we as a team have to do at the Cybathlon this October. Now, as I described earlier, all teams competing must complete a set of obstacles or tasks. And the Cybathlon organization has created 10 of these tasks for us to perform, each embodying situations that we all encounter in our daily lives. These situations may seem simple for us to perform, but in order to do them with an exoskeleton, they require a lot of different design choices. To help better understand these 10 obstacles, we've decided to group them into 3 distinct categories: handling objects, navigating through spaces, and overcoming terrain. Consider moments where you found yourself carrying a package you ordered online home, or where you're walking around in the kitchen and reaching down into a cupboard to grab a plate or a knife from a drawer. When we're doing things and walking, we're constantly using our hands without even thinking about it. It's second nature to us. However, for exoskeletons, this is different. Currently, almost all exoskeletons require their pilot to use both hands for crutches in order to remain balanced. And this is something that the moving parcel task, the kitchen task, and the door task aim to test. In the moving parcel obstacle, the pilot must pick up a box from a cupboard, walk a few meters before placing it on another cupboard, and then continuing. In the kitchen task, the pilot must lean down to grab a knife from a cupboard before turning around and then cutting a piece of bread on a countertop. In the door obstacle, the pilot must walk through a door before closing it behind him and then being able to continue. This highlights the importance of coordination of upper and lower body movement. Next, I think we can all remember situations we found ourselves in public, busy areas, such as taking a train during rush hour and finding a spot to sit on, or making your way through a cafe and getting in line for a coffee. This is something which the train compartment, the crowd, and the free walk task aim to test. In the train compartment task, the pilot must walk sideways and sit down on a set of benches. before standing up and continuing to move. In the crowd obstacle, the pilot must weave between a set of 2 tables, avoiding robots, which are constantly circling around them. In the free walk obstacle, the pilot has to walk a few meters, unaided by any form of external balancing aid. And this may be the most difficult task of all, since the pilot is still able to provide input commands with his input device, but is unable to hold on to anything while balancing. Now, what these 3 obstacles show is that it's very important for the pilot to be able to give precise inputs at precise times in order to choose what speed and direction he wants to have with the exoskeleton. Now, lastly, I'd like you to consider moments during which you've had to navigate over some form of uneven terrain. It could be as simple as walking up a few flights of stairs when the elevator is broken in the building, or taking a small detour when you're walking through your neighborhood and decide to go into the forest. Now, these situations are embodied by the stairs, the high steps, stony path, and tilted path obstacles. In both the stairs and high step obstacles, the pilot must walk onto and over a set of leveled surfaces. In the stony path obstacle, the pilot must set a set of coordinated steps on a random formation of stones before being able to proceed. Lastly, in the tilted path obstacle, the pilot must walk across a sloped surface, requiring extra flexibility in the hips and the ankles to stay stable. What these last 4 obstacles show is that it's very important for the exoskeleton to have a large range of movement to be able to tackle any form of terrain, as well as having the exoskeleton be able to adapt to its environment and change its step size accordingly. By grouping the obstacles into these distinct categories, we now have a better understanding of the challenges faced by people using exoskeletons. And although this may be an oversimplification of the amount of times that someone may encounter these situations, they are a very valid representation of what people living in wheelchairs encounter every day. And as if that was not even difficult enough, to complete these 10 obstacles, we have only 10 minutes. And they have to be completed without breaks in a single run. This shows not only the engineering behind the exoskeleton, but also the skill and resilience of our pilot, Daan. Together with the team, we've been training 3 times a week for the past 5 weeks to get to where we are today. Daan had to make a 2-hour drive from Gaanderen to Delft and 2 hours back in order to train with us. And I think I speak for the whole team when I say that truly takes some dedication. That's no easy thing to ask of someone. And that's why we'd like to showcase the important role of not only our pilot Daan, but also the previous pilots, who we've put in a small video to tell you more about their experiences with Project March.
Ja, ik ben Sjaak Virijns.
Ik ben Daan van der Heijden.
Ik ben Koen.
Ik ben een van de oud-piloten.
Ik heb zelf in March 6, 7, 8 gezeten.
Piloot van team 3 en team 4 en team 5 heb ik mogen zijn.
Ik ben van March 9, de piloot. Het is een unieke dynamiek. Het is jong, inspirerend. Het is vol lol en energie. Maar ook focus wanneer het nodig is. En ze komen met nieuwe innovatieve ideeën. Die weer doorgevoerd worden in een exoskelet. Ja, dit is het eerste team waar ik aan meewerk. Dus het is sowieso een bijzondere ervaring in deze voor mij. Ik kan het ook niet vergelijken met andere teams. Dus voor mij is dit sowieso al een hele bijzondere ervaring om als piloot aan mee te mogen werken.
Ik vond het erg leuk om met studenten samen te werken. Ik heb enorm gelachen alle jaren. Ik denk dat ieder team op zich bijzonder was.
Elk team heeft natuurlijk zijn eigen bijzonderheden. En ook een ander pak natuurlijk. Dus ja, het team heeft daar zich ook aan gecommitteerd, aan een nieuw doel. En aan de hand van het doel ga je toch samen met zo'n team ook op weg. En dat vond ik wel heel erg leuk om 3 verschillende, echt compleet verschillende teams mee te maken. Maar ook verschillende doelen, verschillende uitkomsten, verschillende mensen. Leuk.
Ja, je gaat door een heel proces heen, van het ontwerp tot het maken, tot het in elkaar zetten, de eerste stappen. dan krijg je de foutmeldingen en dan ga je langzaam het verbeteren en kom je steeds verder en ga je uiteindelijk lopen met een pak. En je ziet iedereen steeds ervan genieten, ook al zijn er tegenslagen.
Als ik March met 1 woord moet omschrijven, dan zou ik zeggen gewoon geweldig. Ja, ik denk niet dat ik iets anders wat in de buurt komt kan zeggen.
Inspirerend.
Challenging. Ik vind het echt een enorme uitdaging. Ja, elk team heeft zeker zijn tegenslagen gekend. Ja. Ik denk dat je daarna juist heel erg van groeit, van leert en ook in de toekomst heel veel aan hebt als je daarmee kan omgaan.
Natuurlijk zijn er tegenslagen en daar was ik al van tevoren door gewaarschuwd door de vorige piloten. Dat erin zit. Dat hebben we gehad. Recent nog. De ene dag werkt alles super, de volgende ochtend begin je weer. En dan zijn er storingen en dan krijg je een soort kettingreactie. En uiteindelijk aan het eind van de dag kun je toch nog uiteindelijk wel lopen, gelukkig. Maar dan zit je wel te wachten. Tenminste, ik zit te wachten. Anderen zijn druk bezig met het proberen op te lossen. En dan zit je wel elkaar aan te kijken van ja, wat gaan we doen? Hoe gaan we het oplossen? Maar uiteindelijk zit je met z'n allen in hetzelfde schuitje. Want niemand wil het. Iedereen wil graag verder. Maar ja, het blijft een tegenslag. Ja, uiteindelijk lukt het en daar gaat het om.
Vorig jaar hebben we met March 8 hebben we natuurlijk helaas op het podium een flinke tegenslag gehad. Maar tot het podium is eigenlijk alles super gegaan, waardoor het voor mij gewoon een super geslaagd jaar is geweest. Mijn grootste hoogtepunt met March is wel de allereerste keer dat ik gelopen heb. Dat was wel echt. En ik denk dat ik er 2 heb. De allereerste keer dat ik dan heb kunnen lopen met March, dat is echt een hoogtepunt. En dat ik vorig jaar nagenoeg los heb gelopen, dat was ook echt een hoogtepunt, zeker.
De eerste keer kunnen staan natuurlijk, dat is wel echt een hoogtepunt. De eerste stappen, de eerste sidewalk, dat was echt bijzonder. Dat heb ik nog nooit gedaan in een exoskelet. En dat ging verbazingwekkend makkelijk. Ja, dat blijft bijzonder.
Als ik echt terug moet denken in de 3 teams waar ik echt kippenvel krijg, dat was toch wel in Londen toen wij op Abbey Road liepen. En nou ja, je weet, de Beatles op Abbey Road en heel veel mensen gaan over dat zebrapad gaan daar lopen. Dan wordt er heel veel getoeterd. En op het moment dat wij daar overheen liepen, was het muisstil. En dat moment, ik kreeg er kippenvel van en ook aan het eind van dat zebrapad. En dat iedereen stond te klappen. Nou, ik vond echt, ja, dat zal ik echt nooit meer vergeten.
Ik vertelde net over de Cybathlon. Hoe was die ervaring? Echt Cybathlon obstakels doen?
Ja, een uitdaging. Voor het team, maar ook voor het pak, voor mezelf. Ja, al met al echt natuurlijk fantastisch om te doen, hè, want je adrenaline gaat omhoog. Maar ook van de teamleden, van iedereen in die zaal ook. Hè, dus de ontlading dat je dan op een gegeven moment zo'n object hebt gedaan, zo'n obstakel hebt gedaan. En dat je hem dan ook goed hebt gedaan en aan het einde en dan uiteindelijk ook de winst, ja. Kerst op de taart.
Ik zou denk ik March nog wel een keer willen doen, ja.
Ja, tuurlijk. Uiteraard.
Anders zou ik al moeten zeggen dat ik stopte. Dus ik ga sowieso door met March 10. Ja.
Een advies aan Daan is, wees jezelf. Wees duidelijk in hoe je dingen wel en niet zou willen hebben. En wees niet bang. Ga ervoor.
Om te blijven genieten, zeg maar, van wat er in zo'n jaar ook gebeurt. Of tenminste, ik vind de beste tip die ik zelf ook gehad heb en die ik ook echt aan Daan meegeef, genieten.
Now that you have gotten to know Dan and our previous pilots and know what the intense obstacles of the Cybathlon are, you might be wondering how our exoskeleton will conquer all these challenges. In the next 50 minutes, we would like to give you a visual understanding on how we aim to tackle the obstacles of the Cybathlon. My name is Andrew and I'm this year's motion planning engineer.
And my name is Kiki. I'm one of our mechanical engineers. Together, we will guide you through what the race will look like from the perspective of our pilot by simulating completing a few obstacles. Along the way, we will highlight important features of our exoskeleton and show you which departments were involved with the seamless integration in the exoskeleton. This all starts, of course, with how Daan will interact with the exoskeleton using the input device. It is integrated in the crutches, and through the use of this small device, Daan can control the exoskeleton with just a press of a button. As you can imagine, completing the Cybathlon requires a lot of different functionalities. Think of walking sideways, walking up and down the stairs, bending down, and so on. This requires an intuitive system that can switch between these different modes in a swift manner while still staying safe and reliable. This is called our gait planning system, and our software team has worked tirelessly to make sure it works perfectly without unnecessary delays. So, now that we all know how to control the exoskeleton, let's dive a little bit deeper into what participating in the Cybathlon entails. Before the race begins, we must conduct several tests that ensure the exoskeleton is prepared and safe for Daan to use. We will perform a mechanical check, where we make sure all the connections are tightly secured, an electrical check, where we test the cables and electrical components, and lastly, a software check, which tells us if all communication within the exoskeleton runs properly. To perform the software checks, the exoskeleton must be powered on and remain powered on until the beginning of the race. To prevent battery depletion during testing, our electrical engineers have designed the battery switching circuit, which enables us to perform the software checks using an external power supply. After the software checks have passed successfully, we can then seamlessly switch back to the battery without the exoskeleton being powered off, ensuring that Daan can start the Cybathlon with a full battery.
With all the checks completed, it is time to put Daan in the exoskeleton. This consists of carefully wrapping the exoskeleton around him, which is done by the safety catchers and coach, and then securely fastening him to the exoskeleton, making use of the custom-made fixtures. As a matter of fact, this is happening downstairs under the stage as we speak to prepare for the live demonstration coming up in a minute. With Daan in the exoskeleton, it is finally time to start with the first obstacle, the train compartment. As Martijn already mentioned, this requires a lot of functionalities from the exoskeleton, but this starts with walking forwards. Let's press the button to get the exo to start walking. The input device must reach the exoskeleton wirelessly in order to prevent the usage of extra unnecessary cables, which is done by sending the user's input over Bluetooth. This technology allows two devices to wirelessly exchange data while being stable enough to use in a situation with a lot of people, such as during the Cybathlon or this review. Thanks to the capabilities of Bluetooth, the exoskeleton starts walking, a simple task that you and I do every single day. However, instructing the exoskeleton to take these seemingly easy steps might not be as intuitive as you might think. Let's unveil the mystery behind the actuation of the exoskeleton a bit. We instruct the exoskeleton to start walking by saying where it needs to place its feet. However, this requires a translation of these foot positions into the angles of each and every joint in our exoskeleton. This is where the inverse kinematic solver comes into play, a software algorithm with as its main goal finding the joint angles of each and every actuated joint in our exoskeleton that will result in the desired foot positions. As you can imagine, this is quite a complex task, but our software department has managed to optimize this, ensuring peak performance and safety of the pilot in just a fraction of a second.
Once Daan reaches the benches of the tray compartment, a press of a button commands the exoskeleton to take one final step and then to stop moving. Via the input device, Daan will then instruct the exoskeleton to initiate a sideways gait, allowing him to maneuver between the benches of the train compartment. This sideways gait is enabled by the hip abduction-adduction joint, or as we call it, a linear joint. The core of this joint is a spindle with a nut mechanism converting the rotational motion of an electric motor into linear movement. You can find this joint not only in the hips of the exoskeleton, but also in the ankles, accommodating the upwards and downwards motion of the ankle. While these are distinct joints in the human body, our exoskeleton uses a uniform joint design for both. After a few sideways steps, Dan will take a seat on the train bench. For this and almost all other movements in the exoskeleton, we require hip and knee flexion and extension, which are facilitated by the rotational joint. The basis of this joint is a so-called strain wave gear. This is a special type of transmission that allows us to convert the high rotational speed of an electric motor into a slowly moving output, able to take on high loads. Enough to, for example, lift my weight 5 times. With the mechanical department, we've put special focus this year on a lightweight design for both the linear and the rotational joint. This, together with topology optimization on the frame, has led to a weight reduction of 10 kilograms, making the exoskeleton 25% lighter than last year. After sitting down, Dan will stay seated for a brief moment, then stand up again, walk sideways, and continue to the next obstacle.
The next obstacle is the high step. It consists of 3 steps of differing heights placed in a random order. In order for the exoskeleton to traverse these steps, a way of detecting their height needs to be implemented. This is one of the obstacles where the cameras are necessary because of this inherent random nature of the obstacle. Just like our eyes, the cameras perceive their environment. But how does this result in the exoskeleton taking the correct step corresponding to the box in front of Dan? Unlike how we perceive the world in actual images, the cameras perceive the world as a group of points, a so-called point cloud. A point cloud is a group of points defined in 3D space, which together creates a rough representation of the surfaces in front of the exoskeleton. These point clouds are processed by an algorithm to detect flat planes, in our case, the surfaces on which we can place our next footstep. These flat planes are mainly used to determine the height of the obstacle, since this is the random aspect in this challenge. Using this determined height, we then calculate a trajectory of the foot through the air that will reach the desired height. This trajectory is then fed to the rest of the exoskeleton, resulting in the exoskeleton taking the step corresponding to the box in front of Dan. We will continue with the next obstacle, the stony path, where 10 stones are randomly placed in a grid. In this virtual stony path, we will quickly cover only 2 stones. In this obstacle, the same algorithm is used as in the previous obstacle, so the cameras perceive their environment and converts it into point clouds. However, the main difference is that using these point clouds and the determined flat planes, we now try to find the next stone. Since these stones are placed on the same height, we now try to find the distance to the next stone, as opposed to the height in the previous obstacle. In real time, the exoskeleton then uses this determined distance and the data from the predetermined steps to calculate a new trajectory, which will reach the next stone. This is then repeated for every stone in the stony path until Dan reaches the end of the obstacle.
Next up is the crowd. This obstacle is meant to simulate a crowded environment through which the exoskeleton needs to maneuver. While most of you probably don't think twice when you quickly navigate through a crowded room, this actually requires a lot of timing and agility. To have a spot-on timing, fast communication between the exoskeleton's components is crucial. It allows the exoskeleton to achieve specific joint angles more quickly and with greater accuracy. In previous exoskeleton models, we utilized both a motor controller and a translator to communicate signals from the main computer to the motors in the joints. This year, our embedded systems department have worked on combining these 2 components into one, making the M drive. By eliminating the need for the additional translator, they've ensured faster and more efficient communication within the exoskeleton. Since agility of the exoskeleton is also important during this obstacle, the previously mentioned weight reduction is crucial. Since the lighter the exoskeleton is, the easier it is for Dan to help maneuver it into the right direction.
The final obstacle we will be covering is maybe the most challenging of them all, the balanced free walk. The main challenge of this obstacle is to keep the exoskeleton and pilot in balance without the use of any crutches. Able people often take this for granted, since this is something we rarely think about, but our bodies constantly make small adjustments to keep ourselves in perfect balance. To mimic this in the exoskeleton, a sophisticated algorithm is implemented that kind of looks into the future. In reality, it cannot exactly do that, but it tries to predict what the exoskeleton will do given its current posture. To select the next step, it will simulate what will happen for a set of actions and then select the most optimal one, resulting in a balanced walk.
An important feature of a balanced walk is weight shifting to your standing leg. In order to do this, you need to be able to rotate your ankle inwards and outwards. This extra degree of freedom is facilitated by a newly designed passive joint, the ankle inversion-eversion joint. Unlike all the other joints in our exoskeleton, this one is not actively actuated with motors, but makes use of a spring mechanism. This mechanism is uniquely designed for our pilot to shift his weight to the side a bit, but counteracts excessive sideways motion, pushing him back to a balanced position if he deviates too far. Since we have all these nice innovations for a balanced walk, there will be no need for crutches during this obstacle. Daan will leave these behind at the beginning of the free walk. However, as you might remember, the input device, with which Daan is supposed to end the free walk, is integrated in these crutches. Our design engineers have worked on the detachable input device, so that Daan can take it off of the crutch and hold it in his hands during the free walk.
While we finish up discussing the last innovations, please note that the stage elevator will start to descend shortly. This is all in preparation for the live demonstration coming up in a minute. It usually is a car elevator, but today it doubles as an exoskeleton demonstration platform. So, while this is happening, we want to talk about a final innovation we have made, because apart from the Cybathlon, we have also made great technological strides in other fields, one of which is the brain control technology. It tries to analyze brainwave data to determine if someone is thinking about something in particular. For example, in previous years, it was possible to get the exoskeleton to stop and start walking by just thinking about it. However, with a new pilot, new challenges arise. Everyone's brain behaves differently, and everyone thinks differently. As a result, it is nearly impossible to use the data from previous March pilots and have it work on Daan. Thus, this year, our human-machine interaction engineer has focused on making the process of analyzing those brainwaves more efficient by utilizing a type of artificial intelligence. The result is an algorithm that can quickly decide if someone is thinking about walking or not. While we have worked hard on implementing this newly discovered technique, it is extremely advanced, which is why it's not yet suited as an input device for during the Cybathlon. Nevertheless, we have strived to improve as much as possible on the brainwave control technology by providing building blocks for future advancements, which is the main philosophy behind all the previously mentioned innovations.
We've shown you many examples of how we are trying to push the boundaries of exoskeleton technology. Now it is time to put theory into practice. What we have just shown you in our virtual Cybathlon tour is what we want to show the world in Zurich in October this year. However, we are not there yet. Right now, we are in our training phase. Designing, building, and implementing all these features into an exoskeleton is one thing. Actually training with Daan in the exoskeleton is another. This gives rise to a whole new set of challenges. Daan has to get familiar with the exo and how it behaves, and we need to fine-tune it to his body and movements. We are working hard to achieve this, and we would like to show you a preview of the progress we've made so far through a live demonstration. But first, let us now finally reveal the exoskeleton of Project March 9.
With the final reveal of our exoskeleton, we would love to show you how our exoskeleton will function right in front of your eyes. Prior to this, our demo team has been working backstage to get Dan and the exoskeleton ready to show you the full extent of our exoskeleton. To give you a sneak peek into what Dan will be doing at the Cybathlon, he will traverse 2 obstacles today, the train compartment and the door obstacle. Please keep in mind that we have just started training with Dan, so while we are incredibly proud of his performance, this is not the end point for us yet. For example, during the Cybathlon, we will aim for him to take larger steps to increase his speed during the Cybathlon. But since he's still getting accustomed to the exoskeleton and its movements, we have decided that in light of safety of himself, he will be taking smaller steps today. For the live demonstration, we kindly ask you to remain quiet so that Dan can keep focusing on the obstacle at hand. Without further ado, I would love to give the stage to Dan and the demo team. Stijn.
All right, Daan and demo team, thank you very much for this really great performance. The demo team will now get Daan out of the exoskeleton. And to do so, they will first loosen all the fixtures, and afterwards they can lift the exoskeleton over Daan and put it on the stand, so Daan can then easily hop into his wheelchair. Also, this process of getting Daan in and out of the exoskeleton requires quite some practice. But by now, Daan also knows how to loosen the upper leg fixture and torso fixture himself. So it's a real team effort, and it goes faster and smoother each time again. While we wait for Daan to get out of the exoskeleton, I would like to take this moment to thank all of our partners. And I want to start with a special thanks to the Lauwman Museum for giving us the opportunity to reveal our exoskeleton here. It is a place that represents the history and revolution of mobility, and it has been a true honor to present here today. Building our exoskeleton this year was not possible only with this team. Throughout the year, we had support from all of our partners, who all contributed in their own unique way. Your support, through providing components, funding, and consultancy, have been crucial for achieving our goal. Thank you for believing in us and playing an essential part in our year. All right, Daan, now that you're out of the exoskeleton, I would also like to say a few words to you on behalf of our entire team. We want to thank you for your hard work and time you put in this project. Your first year as pilot of March, and you embarked on this new journey with incredible motivation and perseverance. Throughout the year, you had to have quite some patience with us and with the exoskeleton, but you always kept positive-minded and kept the spirit high. So thank you very much for this year, and we are really glad that you will continue your March journey next year. Thank you. Exactly 1 whole year, this team has put all their time and energy into this project. Today, we were able to give you a first insight into the potential of our exoskeleton. Like Kiki mentioned before, we as a team are not at the finish line yet. We are currently in the midst of our training phase, and training so many different movements with our exoskeleton takes a lot of time and gives rise to new challenges we have to overcome. After a well-deserved summer break, we as a team will continue training to maximize the potential of our exoskeleton and to get Daan and our exoskeleton ready for the final obstacle, participating in the Cybathlon next October. I want to thank all team members for their hard work and dedication throughout the year. It has been a true honor to work with such highly motivated and talented team. And I'm really looking forward to working together the last months. So now I want to ask them all to please join me on stage. The mechanical department, Jet, Jesse, Tom, Kiki, Anna, Sjoerd and Michelle. The software department with Femke, Alex, AJ, Andrew, Nike, Mick, Martijn and Pleuntje. Our embedded and electrical department with Sorana, Kim, Jikke, Jort and Ruben. Our operations department with Charlotte, Daan, Jiska and Stijn. Our management team with Thibaut, Max and Stijn. And of course our pilot, Daan. We are the 9th team of Project March. Thank you all for coming. Klaus.